principles that you are going to want to be familiar with when you're evaluating GitOps. We've got a oh, I had this in another tab, but I have like a million tabs. There we go. Guide to operating Kubernetes the GitOps way. Here we are. Right. We have a lot of resources, but we have this all over the place. These are kind of the 4 guiding principles that we like to think about when we think about effective GitOps at Weave and with the solutions that we build in the community. One is that describing your entire system in a declarative way. This is important because it lets you have reproducibility. We have been through several stages, different movements of configuration with regard to running workloads. And describing your system declaratively has roots in configuration management systems like Chef and Puppet. It has roots in infrastructure as code and infrastructure as data. And GitOps is very much circumscribed within this constraint. Like if you have a declarative system, if you are able to store the declaration of that system declaratively, then it gives you very good reproducibility. You get benefits here regarding disaster recovery in the continuity of your business or say your organization, the services that you provide, the people that you serve. And so declarative systems. Right now, since we use Kubernetes a lot, and we're going to talk about Flux today, which is declarative systems management for Kubernetes. Kubernetes is inherently operating in this way, but there's a couple of gotchas that I'm going to point out that you don't get when you only use Kubernetes. So we'll get into that. Now, storing that data inside of a system like Git. Now, you don't have to have Git necessarily to do GitOps. We have, at GitOps Days, we had some presenters showing us using Perforce, using SheetOps, which is like GitOps driven from a declarative data set in a Google Sheet. Pretty cool. But if you have at version store where people can collaborate and you're automatically applying those approved changes to the desired state, then the last bit is a maturity question, right? So there's really a sliding scale of like getting to a place where you are walking instead of crawling and running, with GitOps. And when you start to get to converging on state and even modifying it to keep it within policy based off of agents that are running either outside or inside the cluster, whether it's a pull or push or event-based workflow, there are various trade-offs there. But having these agents constantly ensuring correctness, alerting you on divergence of state, so like correcting for configuration drift and alerting on that kind of an issue, and keeping things within like a policy, like if you have an image tag policy, or you want to keep upstream changes in sync from, say another repository, then this is important to think about. So yeah, those are our principles. Now, what do you get when you do GitOps in the way that we suggest? With Flux, say let's have a Kubernetes cluster, right? Yay, Kubernetes. 1, 2, 3, 4, 5, 6, 7. There we go. So Kubernetes has this declarative API. You can configure it and you can talk to it from both outside and from inside, right? That's great. Now, traditionally, what you'll end up doing is at some point in your CI workflow, a lot of people end up kind of doing a little bit of a Docker build. And then after that's kind of done, they push their image to some registry, like Docker Hub. Hopefully this is big enough for you folks. Should probably use the full screen. And then as they do that, they'll also kind of do some imperative kubectl commands, or maybe you're using kubectl apply in more of a declarative way here. And then from CI, you kind of use some extra secret credentials like a kubeconfig or something, and then you talk from outside the cluster into the cluster, right? So then you've got your Git repository over here, a little Git logo there, little branches, right? This has all of your files and all your folders. People are collaborating on it. You have Alice and Bob over here, like talking, putting files in, making commits, and then events happen, and CI kind of has this reconciliation loop on the files in Git. They end up doing a build. You push an image to a registry. The registry gets pulled into the cluster as well. I guess that's kind of the other way around. And you have this secret credential that you push on an event-based basis into the Kubernetes API. Now, this is cool, but there are a couple of problems with this. When you have this kind of monolithic CI approach, you can get into some trouble if you don't properly factor your approach to continuous integration and continuous delivery, right? See, when you start talking to Kubernetes, that's deployment, right? You're actually delivering artifacts at that point instead of just producing them, right? And so the point of continuous integration is to produce those artifacts, get them into the registry. But if you couple these things into the same workflow, I just want you to caution you to look out for this in your own pipeline. If that is monolithic CI/CD in the same pipeline, you cannot produce an artifact separately from deploying an artifact. If you can't do only this particular action, you got to fix that. And that's because it makes rollback and things like that impossible. It becomes very difficult to actuate the cluster through the pipeline without talking to the cluster directly. So go ahead and split that up. Now, the way that we recommend solving that problem is instead, I should have drawn some of this stuff in a different order here. Maybe I can just like erase. Got to improve my MS Paint skills, right? The way that we can solve some of that problem is, okay, we'll have the continuous integration system build our images, right? You said, okay, Leigh, let's split this up. So CI does our Docker build, right, to our registry. Ooh, that's a pretty good little Moby here. Yeah, he's the keeper of our images. There we go. So yeah, git fire CI, CI does the Docker build. Now you have a bunch of tags in here, like 500 and 501, right? And then those things are pullable into your cluster. That's great. Now, what if we install Flux, a GitOps operator, inside of the cluster, and instead we flip the credentials around. We give Flux the credentials. We allow it to, on a reconciliation loop, pull from the Git repository. So then if we have this config folder in here, say we can have like another Git, wow, I really messed that up. Config, right? Then you could even have multiple Git repositories and that kind of thing. You know, Flux can be pulling from multiple places. It can also be pulling the image registry, right, and that kind of thing. And so now you've got this pull-based workflow for keeping your cluster in sync. And if you really want, you can also configure webhooks from external systems like Git to inform the Flux agents to simply pull, right? And so this is a huge benefit in terms of security. The other bit here is you no longer necessarily need to give people access to write to Kubernetes, right? Because this cluster right here, that would normally be an important security boundary. But if you want folks to be in a reviewable and an auditable, in a collaborative way, where you can also keep extra documentation, you can link issues and that kind of thing, instead of giving them direct access to mutate the cluster, which would be quite dangerous, right? We can simply depend on the fact that the administrator has given us Git repositories and maybe even the ability to configure other Git repositories to sync from. And when we're using tools like GitHub and Bitbucket and that kind of thing, you already get access control lists. You get like the existing teams and structures that you have in place inside of your Git hosting platform, all of the collaboration, all of the visibility into continuous integrations produced artifacts. You can get notifications back into your Git platform. And so your organization likely already has a very clear story for how to socially collaborate and securely organize change and review and release within your approach to hosting Git, right? If you're a GitHub client, if you host GitLab, or Git internally on your own cluster or in your own infrastructure, you can use that. There's already structure in there in place. And it's not a question of how do I give access to these people. You don't have to create new process. And all of that access is reviewable in a way that everybody can view, or the people who need to view it, can view. So that's the big idea. Now, there's one more other thing that I want to point out before I stop ranting about why GitOps is super valuable, because it seems to, people seem to be getting a little bit doubtful of, why do I need this? And what's so different about this? Why is this innovative, right? So if I say, let's find, some kind of manifest, right? So here's a daemon set. It's actually just a patch. Now, this is important. You can see right here, we're using customizations. So this is not a full daemon set. There's already something more complex here than happening. I'm pulling in a dependency from a remote base, right? I want to extend contour and then modify the way that it works a little bit so that we can scrape it with Prometheus, right? This patch is a intent that I want to actuate on the contour manifests. And if I can store that patch separately in Git, then the commit message around it has metadata about why we're doing that. It might link to other issues. I can go in here and I can change the order of these fields if I think that it's more important, that the port is on top. And those kinds of details, then say, by the way, this is, on top because it's important for X, and Y reason, right? Like I can leave those kinds of comments, I can document this in a way that's appropriate so that my team understands the context of the change. Now, all of those comments, which fields were supplied and which fields were omitted, what was the original API version of the object that we were working with, and then that gets into a bunch of complex things about how API versions are converted and how fields are preserved. All of the order of fields, the way that the document is structured, that stuff is all lost when it actually enters Kubernetes. And so it's important that whatever way you were actually talking about, whatever form that you're actually working with the document, if you're using additional tools like Kustomize or JSONet that are actually going beyond just working with raw manifests, raw YAML files, then you want to be storing, versioning, and collaborating on those outside of Kubernetes. And this is practically a requirement because Kubernetes doesn't have a versioning system that's intended for human beings. So that is, GitOps is super important. GitOps is a good approach. GitOps is necessary in that Kubernetes is not going to take you all of the way. You know, in the same way that you wouldn't just operate a Linux server manually, you wouldn't operate a distributed computer. Maybe you could get away with it as a single person, but you want to keep track of your work as things start to have longevity, and you want to maintain this cluster over time. Cool. Principles of GitOps. Another resource that I want to point you all to is we have a wonderful lab that we wrote. It's the Eks Hands-On Lab. And this is a great intro to progressive delivery if you happen to have access to some AWS infrastructure. We're also going to be linking out in the README of our demo today to the end of this demo so that you can see some good guides for how to work with Canary releases using Flagger. And but there's a little bit of documentation here on what progressive delivery is. We have a blog link to Martin Fowler's kind of definition of what is new and how is the industry kind of converging on these terms. Basically, you know, if you're talking about red, black, or blue, green deploys, if you're talking about traffic shifting, if you want to be doing A/B testing, you're running experiments on metrics, then you know this is kind of in that area of progressive delivery. It's a very new term, so if you haven't heard it before, no worries, right? We're all in the business of inventing jargon, progressive delivery. Now, one thing I want to mention is that when you start talking about wanting to do something more complex than just rolling out the application and having the behavior of traffic shifting change based off of the shape of the infrastructure, right? Like I have 5 pods, 4 of them are from the old version, 1 of them is from the new version. So 20% of the traffic is going to be currently served by the new version. That's the shape of the infrastructure defining how things are kind of, you know, being routed. And once you start talking about like shifting the traffic based off of policy and percentages and weights, you know, we're configuring load balancers. This is really nothing new. But then responding and making appropriate changes based off of some metric. A requirement for progressive delivery and automating around these kinds of mechanisms is going to be good observability. You need to have the maturity within your team or even within your infrastructure to be able to monitor service level indicators. This is jargon from SRE speak. Right? So if you can build a service level objective, which is some kind of parameter by which you would like that indicator, be it a request rate, a response, I guess I can stop sharing and just use my hands, a request rate, a response, then you will be starting to reach that maturity point where you can consider running experiments and talking about what a good deployment or a bad deployment looks like from the machine's point of view, instead of just people calling your support line and saying that things are failing, right? Or you feeling like the infrastructure is slow when you loaded it in your browser. So we're able to use things like Prometheus or other providers like Datadog to give us a stream of metrics that we can look at. And the provider of this service level indicator for us in this case with Flagger and our demo is going to be a service mesh called Linkerd. Now, our progressive delivery operator that's actually going to be performing the automations that we declare inside of our GitOps control repo is going to be Flagger. And Flagger is a great project that's maintained by my stellar teammate, Stefan Prodan. Flagger, it has recently become part of the Flux CD project. It's joined the Flux org. And you can see it's the progressive delivery operator for Kubernetes as we've described it. Flagger is capable of doing those things like A/B testing, release gating based off of external sources. You know, if you wanted to have like an HTTP server or Jenkins flow, you know, where somebody says, okay, this thing is ready to release, Flagger can do that. Flagger can do traffic shifting and make sure that everything is within a certain latency or that you're not seeing a spike of 500s and that kind of thing for status codes. And it's really cool. It's driven by a custom resource that we will be showing you. And let's see, still know how to use this webinar software. I do want to make sure that all of this time is super valuable for you. So if you've got questions, feel free to put them in the chat and I will try to circle back to them. Yeah. All right. Let's move that here and go back to sharing your screen. So I think it's probably good to consider doing a little demo. Who doesn't like a little excitement in their day, right? We won't save that one. So I have a repository. Just get a new window here. Flux. It is a fork of one of Stefan's examples, where I have made things a little bit more declarative. Let's see. Why isn't this loading? Interesting. You see this? Meetup. That is very odd. I'm like not able to pull up a web page. There we are. Okay, cool. Softbox, GitOps, Linkerd. Cool. Cool. So I've got a little bit of a README here. It's modified from the fork that I have because I've moved a lot of the manual steps that Stefan has done previously in other demos into a declarative approach. So what you'll find in here is that we're going to have a declaratively managed installation of Flux inside a Flux system. And then I've got some additional config that's going to be in here. Here I've kind of notated some phases that are going to occur from a dependency tree, I guess it's a DAG really. So we're going to have a installation of Linkerd. This is the Flux customization kind. It's going to be applied into the cluster. So this is different from the customization YAML, right? If you were using customize. You don't have to use customize to use this object. It's just a way of applying plain YAMLs, but you can also use customize on top if you would like. And we are going to be pulling this Linkerd installation from another directory that we have inside of our repo. So this Git repository is the one that'll be bootstrapped into the cluster. That's a different custom resource that you can use in Flux. We're going to have a path here. So we have full control over which repos and which directories at which references we want to be using. And then we want to ensure that after Flux applies the inflation of this Linkerd install, that we health check it to understand if it is available. The reason we're going to do that and the component that we're health checking is actually this Linkerd proxy injector. It's the thing that's responsible for ensuring that when you insert a pod into Kubernetes, that it gets a sidecar that puts it on the mesh. And that's important. Now, I mentioned that there was a little bit of a dependency tree here. We also have a contour and a flagger installation. And if you open up these and look at the Flux customization that applies this directory inside of our repository, you can see that it actually depends on another customization called Linkerd. So we want Linkerd to be applied and for the proxy injector to become healthy before we actually put contour into the cluster. So we're able to define a DAG here, a series of dependencies. And that's important because this means that in a single commit, we are able to express just the contents of a single commit in the Git repository. That's really bizarre. The contents of a single commit in the Git repository, we can express the full dependency tree of complex installations of custom resource definitions and infrastructure that's necessary to be available before other resources are applied. And Flux can then take our declaration and ensure that that dependency graph is met without asking somebody to execute a series of steps in order or use an imperative script. So that's that first tenet of GitOps. Can you specify the entire state of the system in a declarative manner? With Flux, the answer is yes, and we would encourage, if you're using other ecosystem tools as well, to ensure that you use them in a way where that's possible. Right? We'll do the same thing for Flagger. We just want Flagger to be installed after Linkerd is available and running inside the cluster. And then for our workloads, we don't want to install the workload until Flagger is installed, because our workload is going to be using some of the Canary custom resources with Flagger. Now, you could split this up if you would like, so that the Canary gets actuated later or whatever, but I just found that this was probably a good way of doing it. And yeah, here again, we're using the same Git repository, which is the one that we're in, and it's the workloads directory. So I don't have a cluster yet, if I remember correctly. Let's hope that things go well. I've just got this this demo cloned down. The repo that I was showing you up there. And let's do a kind create cluster. Shouldn't take too long there. And then what I'm going to do is a Flux bootstrap. So I'm getting a brand new cluster here, right? And this could be anything. It could be an EKS cluster. We have demos where we've done it with AKS as well. And if you, just making sure, oh, can I enlarge my screen? Thanks, there you go. And what else have we got? Cool. I'll get to that question, Kenneth, at some point. Yeah, so we've got a brand new cluster that we're spinning up. It would be such a shame if we had to do anything really super imperative to get this cluster into a state where we can now operate it declaratively. And there is a little bit of a dance, right? There's a chicken and egg problem, or a bootstrapping issue, where we need to get Flux into the cluster. And then we need to generate some cryptographic identities. In this case, it'll be the SSH keys that are used to configure the deploy keys on the GitHub repository. Flux knows how to do this for GitHub and a couple of other providers specifically. So what I'm going to do is export my GitHub user and token, and then I'm going to do a Flux bootstrap with the GitHub provider. The owner is me. That just happens to be the same as my GitHub user. I'm not using the proper environment variable there. The repo is named GitOps Linkerd. That's under my personal organization right here. So that's what that next flag is. And then the path that I want to be syncing, the very first one that we bootstrap is going to be the cluster's kind0 directory. So we'll go ahead and do that. Well, hopefully we don't run into any issues, but I did just kind of create this demo. And if anything, we'll debug things. Should be pretty well tested though, since we're using GitOps principles and this has worked before. Cool. So what do we see happening here? Flux is going to generate some manifests based off of some customized bases that we maintain in the Flux project. You can use those customized bases directly. We also have a Terraform provider that uses this same Golang code path. So if you're using Terraform and you'd like to do a Flux bootstrap into a brand new Terraform created cluster, that's a thing. Yeah, not a lot of magic happening here in this command that can't be just run again. We like to consider Flux bootstrap idempotent. If it doesn't have an idempotent behavior, we consider it a bug and we like to try and address it. So it works pretty well. Generates those manifests and applies them to the cluster for me. So it installs Flux. And then it configures Flux based off of the options that I've supplied for my repo. It generates a token, it generates a deploy key. It uses my token to configure the repository with that key. And so if we actually go back to the, where in the world is my browser window? Can't find my browser window. I guess I'll use this one. Cool. Selfie box, GitOps, Linkerd, and then we're actually interested in going to the settings page here. I was talking about how Flux generates a deploy key, right? And then Flux Bootstrap is able to then use my token to set up that key. So you can see that this is just added, and that it's a read-only key in this case. And there you go, pretty good. So that's how Flux can get access to your repository. You're not only restricted to using public repositories, you can use private ones as well. We do a health check on the controllers to make sure that they're healthy, as well as that the source is fetched and the customization is applied correctly with no validation issues. So we can do a Flux. You can get the Flux command line tool using brew or just by our releases. Flux get customization or source is git. Here you can see we have one source in the cluster. It's a Git repository that is fetched to this particular revision. I shouldn't say we have one source, there's other ones as well. And then we can also look at the customizations inside the cluster, and we can see that it's applied the Flux system one that contained our other customizations pointing to different directory paths in the repository. And it's starting to actuate that dependency tree. So it's deployed linker D, but then workloads is not deployed because Flagger is not ready yet. Flagger and Contour are currently being reconciled. If we look at all the pods in the cluster, we can see that we're kind of in that state that's being actuated. But keep in mind that I have a Git repository with all of my declarations. I created a brand new cluster, and then I did a Flux bootstrap. So I've never done any kubectl apply. Now, there may be some exceptions to that. Like if you need to bootstrap CNI before you bootstrap Flux, you can do that. And then you can have Flux take over the CNI installation. If you need to put some secrets in there beforehand that, bootstrap your secrets, like if you want some GPG keys or, set up some Azure managed identities or that kind of thing, you can do that kind of thing. But in this case, I've not needed to ever use any administrative write access to the cluster. That's not just within the framework of getting GitOps started. So pretty cool. Our infrastructure is rolling out, so I'm going to go just take a look at that question. I think Kenneth Younger, you wanted to know, going back to GitOps in general, do you ever run into situations where a single team pretty much controls an important repo and other teams need to submit PRs to get approvals? And that seems like it would be kind of too much of, you get into a little bit of an organizational issue there. Yeah. Kenneth says, we've noticed this when moving to more of a GitOps model as it seems to centralize into certain repos like this. And I'd like to just kind of point out that let's see, this is something that's much easier to do in Flux 2. I will point out that in our workloads directory, you're able to actually, like say, here's this front-end deployment. We have an app called PodInfo that we use for a lot of demos. And this is actually being pulled in from another GitHub repository. So the PodInfo manifests, they do not actually live inside my control repo, right? If somebody wants to change the declaration of the deployment or anything, like I don't even see that change in this repository. That happens, from the development team that's working on PodInfo. I can control the release, from here. Here, this is tagged, but you can change this to semver policy. We'll do that later in the demo if we still have time. And that kind of thing. So hopefully that answers your question a little bit. I would say that in the past, the tooling has been a little bit of a struggle. But Brian, you mentioned that we had that blog post about being on the road to Flux 2. And this is what I'm showing actually is Flux 2. This is the new stuff. It's based off of an SDK we put together called the GitOps Toolkit that's made up of several controllers that break up GitOps into its core fundamentals so that you can individually actuate the bits and pieces. Now, if you want to pull a source into a cluster for any particular reason, you don't necessarily have to apply that source to the cluster. You could use it to build something or transform it. You could use it as a notification center to make changes to other things that fetch other sources. So it's pretty fantastic. I'm so excited about the APIs that we are building with Flux 2 and the community. very much GitOps is something that is maturing. People have adopted it into their organizations and felt the pain points, like you mentioned, with like that, having that very central, huge mono repo. In this case, I would say that what we're doing here, yes, it's a control repo for a cluster, but it's very much not a mono repo. You can see that we're pulling in dependencies from other places. I'll also show that in infrastructure, Linkerd is actually installed from a Helm release, right? So this is another way to help manifests kind of come from other places and be generated through different ways. This Helm release comes from a chart. This is the chart template. And the chart template comes from a particular source. This could be a Git repo or a Helm repository. So, whoever controls that repo controls this release. And again, you can release via tag or policy, a semver policy here. So lots of control over how you delegate the actuation of the cluster to different kind of domains. And again, like when you have the tooling, say you're using Chart Museum and GitLab. In GitLab, you can have multiple repositories, or you can even give different teams access to different folders. In GitHub, you have owners files and that kind of thing. So hopefully I'm kind of addressing a little bit of the concern there, but definitely a pain point if you're not thinking about how you want your organization to collaborate with each other. This is really important. We don't pin you into a corner anymore. I mean, really, Flux 1 was very much assemble your own platform, and figure out your life. But Flux 2 is a toolkit that gives you very good guiding principles, but it doesn't force you any particular workflow or organizational topology. You can build exactly what you need. And that's exciting to me, being, from that kind of background as a platform team member in several teams. But, hopefully I addressed your question. Awesome one. I'm guessing that our infrastructure rollout is probably done. Yeah, looks like, we had a little bit of certificate generation here at the bottom. We have Envoy running as a daemon set here. Oh no, that's just a single Envoy. That's right, I'm only on a single node cluster. And yeah, we got Flagger. There's a front end and a back end deployment of pod info. We could, instead of just like trying to manually verify, I could ask Flux, what are the customizations that have deployed? And yeah, apparently it's reconciling Linkerd again right now. This happens on a loop, so that's expected. And here we see the revisions of the sources that we're at. We also can pull any of the latest changes. Flux just made sure that my manifests were up to date here. That's a good thing. And so that's for managing the Flux installation itself. Cool. Well, that's GitOps, the value of GitOps, and reproducing a cluster's infrastructure declaratively from a repository, right? Pretty awesome. Now, we also talked a little bit about Flagger, progressive delivery, the prerequisites of using service level indicators like metrics, those metrics coming from potentially something like a service mesh, or ingress controller with statistics like a Nginx ingress or Contour. So today what we have is Contour and Linkerd deployed into the cluster. That was done through our GitOps control repo, right? Contour, Linkerd, here's the dependency graph in Flux system config. Make that a little bit bigger for y'all. Thanks for mentioning that earlier. And we have our workloads. Now Flagger is controlled by the canary object. Here we have an interesting example. It's an A/B test. And what you do with a canary in Flagger is you target some very normal kinds of compute workloads in Kubernetes. You can use a deployment and a horizontal pod autoscaler together. If you point Flagger to those with a canary object, then what Flagger will do is very smart. It creates a copy of those objects for you as a consequence of your canary policy. And this allows Flagger really to direct traffic to two different copies, one being the one that you mutate, the canary, and then the more latent downstream copy being the primary one that actually receives all of your production traffic. The great thing about this strategy is you can actually use Flagger on an existing deployment that's already receiving traffic. If you've got a deployment available, you want to install a mesh, you can like modify the next deployment and hook it into a canary, and Flagger will shift the traffic over without you having to tear down all of your infrastructure. So pretty cool. That's the target ref there, and the autoscaler ref, which is optional. Now we get down to, oh, here's the service. You point Flagger to the service. This is so that Flagger knows what group of pods to basically set up as a backend, whether it's the canary backend or the primary backend in your mesh. So that's important. And then here's the analysis section. So this is where we tell Flagger, based off of some metrics, the defaults are going to be provided for us by the service mesh, which is a neat little hat trick in terms of observability maturity. But you can also specify your own metrics here if you would like to be performing more involved experiments, custom metrics from different providers. But here we can set up the analysis. There's an interval by which Flagger will perform several iterations of analysis according to this spec. And then here's something kind of fun. Instead of actually shifting traffic in this case, this particular canary is going to be doing an A/B test. And what we'll be doing is isolating Firefox users. This is one really easy way to actually get session affinity if you're working on a front-end application, because browser usage usually stays very stable in terms of percentages of user bases. So if you only want to target 3.5% or so of your user base, you can find one of your browser's user agents that represents that portion of your user base. You know, as long as the difference in browser isn't incredibly meaningful, you know, in affecting your test, that's one way to get like a very stable session affinity source is by user agent. You can also use cookies here and that kind of thing, which would be smarter, but require a little bit more orchestration and platform integration. Here, we have the actual metrics that we want to be watching. So we have particular thresholds and whether or not we want them to be within a minimum or maximum. And then, yeah, so like if we have requests that are going over 500 milliseconds, you know, that's a pretty bad sign. And then similarly, we want to keep the request success rate over 99%. These intervals are the query buckets by which we're asking Prometheus for data. And then that is going to be happening every one of these analysis intervals. So those things are, you know, subject to tuning and that kind of thing. Time series data is just as much art as it is science and math. So take that for what you will. But the kind of examples that we have do tend to be pretty good. Also, there's hooks. So you can say that when a deployment happens and that like we want to run an acceptance test before we actually start the canary. Okay. So before we actually even send anything to the canary, let's try to make sure that this particular command metadata that's sent to the Flagger load tester service, you know, happens to work. This is a service that you can run in your namespace. It's not a required part of Flagger, but a lot of people do use things like this, including the one that we maintain in the project. And the Flagger load tester service has a couple of like network tools that you can use, like Hey and curl for load testing or, you know, formatting requests. And here you can send the load tester request to do curls, you know, or to do one curl against the canary front end, you know, and make sure that it returns a token. Similarly, instead of doing a pre-rollout, you can do a rollout test. So during the rollout of the canary, we can ensure that there's actually some synthetic load. That's because maybe we are rolling out the canary during a time in which you're not, you know, getting a bunch of requests naturally or organically. You can inject some synthetic load in here using the Hey command line tool. Brian's added a link to the Hey tool in the chat. And here, you know, we have some concurrent connections being fired again at that same service to make sure that it's returning within a successful amount of latency and success rate threshold. So canary policy, here's an A/B test. Let's go try it out. In order to make Flagger notice that it needs to perform a canary, what we will do, I'll just show you those copies, is in the front end, we can get the deploys. Might as well, let's just get all. Oh, there we are. So I mentioned about how when you create a canary, Flagger will actually initialize and create copies, right? So here we've got the pod info service that actually comes from our control repo. These two things, canary and primary, these don't come from our control repo. They're not defined. They are a consequence of the canary object. Similar to how you don't store every pod of every replica set in your control repo, right? They are consequences of a deployment existing. When you create a pod info service and you target it with a canary object, which is right here, you can see here Flagger has initialized this canary, it will copy the service into two other backends that it can point the service mesh to. So then we can do weighted routing, we can send users that match a particular header to the canary, right? That kind of thing. And that's what we'll be doing for the A/B test. Also, those services point to different infrastructure. So if we want there to be a canary, we can actually use the one that's defined inside of our control repo. Here's our load tester. And then we make a copy that's not stored in our control repo. It's the consequence of the canary existing. And the traffic actually gets shifted over to the primary. So, pretty cool. And then what shall we do here? You can see that here's like the autoscalers for those two things. There's a copy of the autoscaler. Also, if there's config maps and secrets, by default, Flagger will also copy the config maps and the secrets over so that you don't get like weird version bleed there. So that's a very important feature as well. That's a huge gotcha. It actually saves you from a particular type of downtime that can occur when you don't manage your config maps properly, because Flagger is capable of rolling back these objects. So pretty cool. And let's go ahead and actuate a release. I'm going to go into the front end repo and then release a new tag. Before we do that, let's just go ahead and port forward. There's a load balancer inside of the contour namespace here that would be publicly available if you were on a public cluster. But since I'm using a private kind cluster here, I just have to port forward to it. There should be a deployment that I can access now over the network. Here, I'm using the XIP.io public wildcard DNS service to return me a localhost IP address. And that's so that we can have a host name that we can match against for the contour ingress. So here we've got pod info running, right? We have a really awesome cuttlefish logo. And if we just want to deploy a new service, then we can update this tag on the Git repo that's being synced. So just if there's new manifests that have to be on the new tag, those things will get deployed. Similarly, you know, you could use a customized patch here or something to override an image tag. That would be done here. I could override the image directly if I wanted that kind of control. And we will, using too many windows, I'll just use this one. Diff. We will release the pod info front end to 501. Since I'm using private infrastructure here as well, because it's a kind cluster, I don't have a webhook set up. I guess I could do something like that with inlets or something. But instead, all you need is, as a developer, to be able to like run Flux reconcile, or if you wanted credentials in CI to run Flux reconcile for you as an alternative to webhook, is access to annotate a Git repository. So there's actually particular verbs for that kind of thing. And you don't need write access to a bunch of stuff. So you're able to tell Flux to reconcile if you want that good developer experience and you don't have webhook infrastructure available. Here we see that we moved to this particular commit ref, and that after we asked Flux to make sure that everything was up to date, you see we very quickly got to the new ref. Right? We can also look to see that the dependency tree has been satisfied. And there are all those, right? So I imagine then that if we were to look at the Flagger logs, which is one way to kind of keep track of what's happening. Yeah, I probably should have even been in here a little earlier. You can see here it says starting canary analysis for pod info frontend. Right? There's logs up here as well about like complaining about metrics providers not being available. You can see that at some point it would have wanted to initialize the front end. I don't see the log message, but it created a bunch of copies of things for us. And then you see here that right now it's going through iterations of an A/B test, right? So here I've got this in Chrome and we're on version 5, but we're doing an A/B test for 501 to Firefox users. And if I open up Firefox, you can see that we're getting a completely different version of the application through our service mesh from the same exact URL through two browsers that have no difference in configuration except for the user agent that they're sending. Right? So that's a Flagger A/B test. And if we actually keep watching, should be able to wait around for another 20 seconds while I try to figure out more about how to describe just like how amazing of a capability this is. I mean, again, it's like if you are matching on a user header, you can easily select like iPhone clients, Android clients. If you just only want to run an A/B test against them, it's possible to do that kind of thing. Similarly, I think you can match against other headers, not just like user agents. So if like you wanted to send people who do not track like a special message, it's possible to do that kind of thing. So here what we can see is that we reached the 10th iteration successfully within our proper metrics, right? So all of the requests were more or less successful, over 99% of them. So it said copying the pod info front end, which is our canary, right? That's the object that we modify inside of our control repo. Copying that template spec to pod info primary. And then normal Kubernetes rolling update happens, right? So you actually get the benefit of multiple ways of doing zero downtime deploys. And you're kind of decorating right in front of changes to your infrastructure. Flagger is able to detect those changes, enforce a policy, run some analysis for you before actually promoting it to the normal Kubernetes rolling update. You even saw there that while it was doing that rolling update in Chrome, we were getting 50% of the requests coming from 501 and 50% coming from the older version. So the A/B test still gets you that rolling update after it succeeds. There's also ways to like skip this kind of analysis and that sort of thing. And that's the power of progressive delivery for front-end applications with sticky sessions. It's important that you kind of have a sticky session for most front-end applications because you won't have that like level of routing maturity it makes it complicated to develop for if like your JS bundle is going one place and some of your API requests are going another place and some of your API requests are going to a newer version of the app. So giving your developers the luxury of being able to have an affinity, like a little bit of session affinity with the user, either through like an opt-in cookie or through selection of the client headers is it's a nice capability, so they don't have to worry about version skew and that kind of thing. And yeah, shout out to Inlet's cool project for creating cloud native tunnels. And one of the big focuses where it does excel is in say, like if you wanted to do webhook development on your personal machine with something like Kind. Pretty cool. And Grok as well, would be another good alternative, or S-Tunnel and all those other services. I've been using ngrok for a long time. Cool. Let's talk a little bit about the other deployment mechanisms, and then I'll try to attempt to demo some failure. Brian, did we have like a time block that we were like targeting, for ending this? I know that, I joined a little bit late. Sorry about that. Thanks for waiting for me. But we really have hit like a lot of the principles of what makes GitOps great. Why doing declarative progressive delivery with an operator is awesome, and there's extra resources for people who want to clone the repository and that kind of thing. Want to be respectful of your opportunity to use this time appropriately. So.
Yeah. So what I was going to suggest, and this is kind of up to you. If you want to go for an extra couple of minutes or 10 minutes, 15 minutes, it's up to you. If you want to go ahead and close out now, it's up to you as well. I did have like a couple of questions I thought I would just kind of ask you, just a little Q&A, but it's kind of up to you. So what feels right?
Yeah, I would love to do some Q&A. I think that would be awesome.
Okay.
Yeah.
So some of these questions are just a little ad hoc. And so I'm just kind of curious about a couple things. And so anybody else that wants to add a questions or put questions in there, I think I can click this button that starts a Q&A session or something. Feel free to. So I wanted to say, first off, that was a fantastic presentation. I really enjoy the fact that you can bring up Paint with, it looks like, Windows XP and do really well. So
like my start button.
Oh yeah, that was great.
Yeah.
And so I thought that was a really great presentation. So kudos to you and your skills on that.
Thank you.
Really, yeah, no problem. You really summed up a good story that I feel like is kind of impacting the community a little bit. And that is kind of the Kubernetes complexity. And you kind of show us these amazing tools. And for everyone that was kind of picking up with progressive delivery and the service mesh at the end, the amount of control that you have by sending, data to, say, a user agent for Chrome or something along lines of that, or even names of people, right? I could send, able to Amazon.com 2.0 compared to .com 1.0, right? It just kind of depends on what you're doing. And so thank you. That was such a great way of showing us the
That'd
control.
be wild.
Yeah.
Like some header indication of like a user persona,
Right.
if you're like bucketing people.
Absolutely. So what I wanted to ask is, I feel like GitOps is still a relatively newish term, but it's not. I think it's been like 2 years now, 3 maybe. What is some of the biggest transformations you have seen and let's talk, from a developer by himself adopts GitOps to, let's go to an extremely large enterprise, because I know you work with all of them in between.
Yeah, I would say some of the most intimate lessons that I have learned from employing GitOps were actually like being a practitioner. And so when I was working on a Kubernetes-based, application, it was a platform for several applications at Beatport, right? We were doing web services, we were doing batch processing, we were on bare metal, we were in Google Cloud, we were moving data over from AWS and that kind of thing. And just keeping track of all of the infrastructure as an infrastructure team member was an enormous task. And there was a mixture of things that were well managed and documented, mostly because there were pipelines that were, either eventing or syncing off of Git. And then there was stuff where it's like we had deployment scripts and we had to, like break away from Terraform because there were options that were, not available. And so we put them into scripts that could be run over and over again, that kind of thing, And so you kind of have this like ideal where you're like, I want things to be idempotent, but sometimes the API that I need to do that is Edge, and collaborating with your team to build systems, systems of working together, that gets you to be able to keep hands over your infrastructure, change it, communicate how it looks, make sure that it's maintainable when you are on vacation or when you leave ultimately. That was like the biggest learning points for me. And that was a medium-sized team. Now, when we kind of work with much larger teams, or like say when I was harkening back to my days of like Puppet configuration management, which was very similar in shape to what we call GitOps right now in this movement. There's a whole order of cross-team and cross-organizational issues, lack of ownership over things like DNS when you might need those, or maybe too much access when things should be locked down and more secure. And there's frustration, there's seat turning, there's mixed incentives and performance reviews, and transforming the way that you work with the infrastructure so that people don't grasp control over it, so that they don't hide visibility of it, is possible by using your organization's crosstalk at Git. Like when I was at AT&T, there was a lot of communication of what projects looked like, and you could go and you could check out the source code of a team that you weren't on, if they were doing something similar to you, and that turns wars into collaboration. And if you can do that with the infrastructure, which is typically a long pole in the tent for delivering something important, then that's the ops part of GitOps. That's the magic. It's really fantastic. So hopefully that addresses your question a little bit there. Obviously, lots of other great things like being able to manage a logging platform, or like actually help people adopt metrics in a standard way across the org. Like if you're doing that with GitOps, it's you've got an approach, which is half the battle. Right.
Yeah. Right.
Yeah.
Right. No, that was a really good way of putting that. Thank you for sharing. Hey, so real quick from Andrew. So, as a relatively fresh area for myself, would you be able to briefly touch upon how Flagger integrates with the service mesh Linkerd to influence traffic?
Yeah, this is super cool. I wish I would have drilled this in a little bit more. One thing about the service meshes is that they've all got, kind of different shapes and styles of APIs. There's a little bit of standardization in there in something called SMI, the service mesh interface. And a lot of the projects that we've integrated with Flagger are using SMI. But like, yeah, say you want to use Istio, right? Or set up, a bunch of things in Contour, or you want to use Nginx Ingress. The way that you would say do traffic shifting, or even just traffic splits, because traffic shifting is actually the flux of traffic splits. It's the constant change of those numbers, right? But if you just want to configure a traffic split in Istio, it is like 9 objects. And if you want to do that in Linkerd, it's complex and it's different. And if you want to do that with Nginx Ingress, it's simpler, but it's also super different. And Flagger is able to actually give you a single object. And then you hook up Flagger to your mesh or to your Ingress controller, the ones that we support. And you don't have to create those objects anymore. You don't have to necessarily worry that much about virtual gateways and services and routers. You don't have to like set up traffic split objects and that kind of thing. You can define a succinct method or a succinct kind of example of the values that you want to start with and get to in a short format, and it will create those objects for you on the back end. And to target your question from a little bit more of a technical angle, the way that Flagger does this is through the Kubernetes APIs that these service meshes and Ingress controllers support. Whether that's formal through config maps and things like that, or informal or formal through like custom resources like with Istio and Linkerd and Console Connect and things like that. That is a great question. Super cool space. Everybody is new to progressive delivery in Kubernetes. Like these are brand new mechanisms. Nobody's a veteran, but there certainly are some folks out there who've been doing this for a little bit of a longer time at web scale companies, and now it's just kind of the democratization of that web scale infrastructure into consumable technologies.
That's a good point too, because I do see mixtures of teams, right? Some teams where they're all in on GitOps, and then you have the teams that like I don't even know why I'm pulling instead of pushing. So good point. So yeah, thank you for sharing that. So a couple of questions I noticed in my dog. Apologies. One question yeah, everyone can come see the dog. So one question I had was, GitOps, there's a big attraction to it. There's so many good things. It's audible. It's great for compliance. It's great for deploying. So what's the gotchas?
Devs know Git.
So what's the gotchas? Is there any gotchas?
The gotchas of Git, of GitOps. Well, Git is just as big of a gotcha as it is an advantage. That's for sure. Right. Yeah, I would say that we've got a lot of work to do to make Git more approachable. Certainly the Git project itself has been improving many of the rough and dangerous edges of the like knife-handled hammer that Git is. It's like you've got to hold that thing carefully and like very precisely to do what you want, or it may slice your tendons. So content warning, sorry. But yeah, I would say that that's a huge gotcha. Another thing is that sometimes folks are concerned about reconciliation quickly. The interfaces that we have, I mean, really, it's not that big of an issue to be polling every 30 seconds, honestly. You can do that. It depends on the size of your repos. If you want a longer polling period to reduce the network traffic, having some webhook infrastructure to quicken things up makes that very similar to like the kinds of informers and controllers that we use inside of Kubernetes. These are proven techniques to get both a pull-based model in terms of security, but a push-based feel in UX. Surfacing notifications back to the developer is always a problem area. Regardless of what you're using. What's the user experience? What's the developer experience that you want somebody to have when they consume your platform, when they iterate on your infrastructure, when they're building their app? And there are some open interfaces for how to do that. Not that it's easy, but we hope that with Flux that we would make it easier. I would say that another gotcha is that sometimes people just don't want to commit. And that is sometimes a confidence thing. Sometimes it's just like, this is not ready yet. I don't want to push this yet. And creating that safety, creating that emotional feel that like, I will just push this. It's for development. I have no idea what I'm doing, but I'll push it, or I'm responding to a production incident. I don't know if this is going to fix the problem, but I need to actuate the infrastructure so that we can respond. I'm going to push it. I'm going to commit this to Git. It's auditable. It's up there. People can see, and you have to use Git to do it. So whatever your client is, whether it's the Git command line tool or VS Code or Git cracking.
That's a good point. No, everything you listed. Yeah. I think the very last one I never even kind of considered. Just the fact that it's up there, it's audible. It's almost like a people culture kind of problem.
Yeah, it's one of those things that you only feel when you start to do it a lot, right? You're like, I'm not sure about this. I don't want to, this is not ready yet, but you push it up anyway, and you're actuating the infrastructure. So it's a change, right? And you want that change to be versioned. And
one question I had too is, I heard secrets was sometimes a challenge. So I put a link into Mozilla's SOPS, but I mean, I would like your opinion on this. What do you think about secrets?
Secrets management is definitely, there's a couple of schools of thought. I personally really like the secrets management approach of using encrypted secrets in a repository. This is something that was already in place when I showed up at Beatport, and I was like, this is awesome that this company has a culture of versioning their secrets. There was some sharp sharper edges around the tools that we used there, but we did eventually adopt SOPs, as well as like some integrations with 1Password. And I try to like inform my opinions from, you know, what I've kind of had to really suffer through before. So why is encrypting secrets or using a KMS, like, you know, from your cloud provider or from Vault actually useful? Why is it a good way to do it? And one is that, again, it's a pull-based workflow. It's safe, you know, only the people who have the keys can actually read those things. You can do auditing to prevent that kind of disclosure inside of your repository by looking for high entropy keys, or with Kubernetes, you know, secrets would be inside of a structured object that you can actually scan the repo for. So you can prevent people from having unencrypted keys inside your repository. You don't have to give people access to the cluster to get secrets into the cluster. You can do asymmetric encryption if you'd like, which means that you can give people the ability to author secrets without reading them back. That's a feature to me, because like, I don't want you to really have your hands on the database, you know, password. But, you know, feel free to generate one. I'll have to trust you that you didn't save it anywhere else, but let's trust that our tools at least encouraged you to do the right thing, you know, the trustworthy thing. So I really like SOPs for a lot of those reasons. Another reason why SOPs is super powerful is because it allows you to have a multi-key and multi-backend approach. So you can actually use multiple KMSs from different cloud providers to back up your secrets, rotate them, as well as have like a GPG backup for offline storage, which is like a very mature solution. There's a lot of people who are doing wonderful things with Vault. It's possible to integrate Flux with Vault either at runtime or in the repo using SOPs and Vault together. I recently demoed the GPG stuff. Stacy just linked to our YouTube playlist, and that was just this week. Super fun. One gotcha that I ran into with SOPs is that's different from sealed secrets. Sealed secrets lets you actually add keys to an existing document without having the ability to decrypt the document. So it's that asymmetric flow, right? You can author keys, you can append keys to a document. But SOPs actually does a message authentication code that's based off of the hash of all of the values in the document together. You can only decrypt it if you can decrypt the MAC or something like that. So you can't append to it without having a decryption key. The solution to that, if you want like an author-only workflow, is that you just regenerate the entire secret or compose it in a different way. But I thought that was a peculiar limitation. But yeah, you know, some comments there.
No, that was interesting. Thank you, especially that last part. Okay, so I have two more questions. I'm definitely not going to take any more time. We're almost at 6:30, so two more questions. So I was just kind of curious, because you know, you all coined GitOps and this huge movement. What do you think? Do you think GitOps? Do you think operators? Do you think both? What do you think? Where do you think people should be heading? I'm just kind of curious on that front.
I'm trying to understand like your question completely. So, you're mentioning operators a little bit. Could you ask it again?
Yeah, I guess my question would be on the lines of, would you recommend like a team start out, you know, deploying things with operators compared to using something like GitOps Flow, or both, right? Do they work well? I'm just kind of curious what the position now. Yeah.
My general stance, being somebody who's built controllers and operators for various legitimate reasons, is that there are a lot of illegitimate or very bad recommendations for people to be building controllers and operators directly against the Kubernetes API. There are so many footguns there. Even just like shaping your CRD in the correct way or handling upgrades to the CRD is a huge challenge already. And then like you have to have somebody know how to use the Kubernetes client within the context of a reconciliation loop to build logic that will reconcile if it fails at any point, which is a bigger challenge to test against and solve than anybody should be really interested in having a generic skill set for. Like that's a very specialized skill. My co-maintainer for the Ignite micro VM that uses Firecracker, Sunny, he's actually working on a project right now that's not really ready for consumption yet, but it's definitely going to be an avenue for people to write more accurate reconciliation loops and have to do less testing. Very excited about Sunny's work there. His GitHub handle is darkowlzz, and you can just take a look at the operator toolkit stuff that is on Sunny's repositories. And yeah, I would say that like wrapping every single application that you have in an operator just because is probably not a good recommendation. It's going to introduce a lot of attack surface and maintenance surface, even just upgrading the Kubernetes client in that massive piece of software that's now actuating your thing. Stuff like operator framework, it's definitely making it a little bit easier, but you really need a reason to want to reconcile some state inside of the Kubernetes API to actuate your application. There are much more generic projects. Like we should be gluing things together, not creating specialized solutions for everything that we do. Yana from AWS now was just kind of talking about her change in opinion about the value of cloud native interfaces and gluing things together just today. So yeah, that platform team member, that DevOps person, that infrastructure operator, similarly, any developer, kind of understands, okay, like I want to take this library and this library. They do these two generic things. I don't want to re-implement them, but let's put them together to make something special. Let's get something greater than the sum of its parts. That's the power of like the generic APIs in Kubernetes, is that they work in as like these super useful abstractions that everyone can generally understand. You're not like looking at something special when you look at a bunch of manifests. So that general recommendation, I think, the overwhelming majority of people should not be building operators.
Yeah, I agree. I definitely, that very last, yes, don't do that. No, that was a really, really good way of, I mean, to your point, and you mentioned the building blocks, and I did put that tweet because I actually saw it myself. And it really is an important thing, right? Like, there's a lot of people before us that built this infrastructure. We need to keep kind of building up together. And yeah, I mean, it really is a fundamental aspect. It's, don't reinvent the wheel, right? Everyone else has kind of already done it.
Yeah, and I mean, like that's kind of the whole point of like the undifferentiated lifting thing, right? It's like we didn't want people assembling their own servers anymore for generic compute,
Right.
Like serving stuff on the web like was a common enough pattern now that companies like AWS could come in and serve that need for you without you being concerned about what Broadcom NIC was inside of your, X and X motherboard. So
right. Well, okay. So I got one last question, and then I think we should close out. First off, so I'll go ahead and say the question, and then we'll go ahead and close out from there. So I'm just like repeating my head as reading this comment. Actually, let's read this comment. Last question, close out, and we're done. So this very last comment, which was from Andrew one more time, which is, how would you look upon Flux accessing secrets from Secrets Manager, utilizing customized to rotate modified secrets and redeploy affected services based on secret generator? Yeah, that's a definite. So you want to go ahead and take that one?
Yeah, this is cool. In terms of using a controller to generate secrets, if you want to have your secrets encrypted and checked into your repo, if that's how you want visibility and reproducibility of your infrastructure, then it's a great bootstrap story there. And the controller would simply need to be generating those secrets, checking them into the repo, and then they would end up in your cluster. Whether you would be mutating the secrets or using immutable secrets, which is new as of Kubernetes 118, you would simply be producing secrets with like a hash at the end, or a timestamp or some kind of incrementing monotonic number, or a GUID, and then you would be rotating those secrets and either mounting them into your application and watching them change, or redeploying your app when they change, depending on what that rotation cadence is. There are tools to help you with rotation. If you would like to rotate them at runtime, there are things that you could manage with Flux, like a vault injection secrets style operator thing, right? And so you would deploy that into your repository. Again, you get the repeatability of the infrastructure. As long as you bootstrap Vault correctly, unseal it, point it to the storage backend, you're good to go again. So lots of good ways to approach that problem. Very excited to see more mature examples. Lots more users adopting good secrets flows with GitOps in Kubernetes. Great question. Mm-hmm.
Okay, last question, close out. I truly am very curious on this. Where do you see our future problems or future going with GitOps, just in general? Some of the things I kind of see sometimes is I see, spinning up Kubeflow, right? Or spinning up Terraform. What do you think is the future? And, it could be anything.
I'm pretty excited about what this release that happened just yesterday for kind of a hiding the node abstraction of Kubernetes. Google just released GKE Autopilot. That's pretty cool. There's certainly space for things like virtual kubelet to make infrastructure a little bit more transparent. But there's a huge problem space there right now, which is that we've built a lot of ecosystem tools around how infrastructure with Kubernetes is canonically assembled. But there are more ways to assemble Kubernetes than the way that we usually do it right now. And so that creates some interesting challenges. When you see some of that more kind of functions as a service composing with long-running container infrastructure, stuff like Knative, stuff like Tekton, where you're doing build pipelines and that kind of thing on Kubernetes. Somebody from the Knative community actually built a example of Knative functions firing off of notification controller. And this is cool because it points a little bit to the future of extending GitOps with the same kind of flexibility as like running Bash inside of a cron job, right? This is the ability for any developer to make a quick function and then using credentials and other secrets that are inside of the cluster right back to Git, actuate something in an OCI registry. And so there's a huge future here that I'm excited about as folks build more active reconciliation pipelines and we collaborate with the robots in Git more. I think that it's part of a story for multi-cluster management that's sorely missing right now. Breaking the cluster boundary is tough. I've got an example. I did a demo at KubeCon last year where we stand up a mesh of gossiping BGP peers across several kind clusters. If you're interested in multi-cluster networking, that's pretty cool. It's bootstrapped with Surf, also done with Flux 2 in a GitOps way. So it's a lot of different areas here, but the cloud native community is super exciting, and helping bootstrap like complex global infrastructure, edge infrastructure, reproducing things, working in a collaborative way. It's all super exciting to me. Yeah. So, Brian, your questions are so good. You're such a good host.
No, thank you. Hey, thank you so much for coming. Honestly, I posted your YouTube link from your multi-cluster networking. I also posted one last little tool that I found out by Fidelity. It's really cool. It's kind of like stacking different layers.
Mm-hmm.
I think you already know about this one.
This is
and
cool.
Yeah, I just want to say once again.
Built on Flux 2.
Yes, it is.
Mm-hmm.
So thank you so much for coming. It's been an absolute pleasure. Thank you, Weave. It's been an absolute pleasure. Last but not least, everyone, I'm putting in the discount code back into the chat. And I guess we'll see you next month. Thank you so much, Leigh.
Have a good one, everyone.
Thank you. Bye.